right? As easy as that. So कन्वेंशन, चलिए अब आप चूंकि आपको आपने सिर्फ क्वेश्चन बनाने के लिए क्वेश्चन बनाए हैं, इसलिए मैं बता रहा हूं आपको कन्वेंशंस हैं आपके एक्सेसेस के लिए, कन्वेंशंस हैं आपके दैट सो कॉल्ड व्हाट शुड आई से फंडामेंटल प्लेन्स के लिए, कन्वेंशंस हैं आपके, कन्वेंशंस हैं आपके ओरिजिन के लिए, कन्वेंशन है आपके पोल्स के लिए. So now you imagine your Earth. The Earth would have a, or you imagine as a conventional terrestrial reference system. That system would have a origin. So you have to define a convention for defining the origin. That would say it is center of mass of Earth. Then second point, where would be the z-axis? So if in order to define this, just a moment. तो आपने डिफाइन किया कि the third axis, which is the z axis, is identical to the mean position of the earth rotation axis as defined by CIO. The x axis is associated with the Greenwich meridian. Then the third, which would be orthogonal to these two and would have been for performing a right-handed coordinate system. So these are the conventions. अब आप खुद ही सोचिए, you cannot reach to origin, you cannot fix the earth rotation axis, but you have made those assumptions which are providing you this facility to define a coordinate system. Now once these assumptions are in place, now your Newton's law of motion would be applicable. You can compute, you can work on it. Did you get my point?
Yes, sir.
Yes. Second is how fifth fundamental catalog FK5 is useful for understanding. For understand नहीं, grammatically भी आप अपने आप को correct रखिए. For understanding the reference frame. What do you mean by fundamental catalog 5? चलिए बताइए. अरुण बताइए what is fifth fundamental catalog FK5?
Sir, FK5, sir, yes, sir.
बोलो.
Sir, FK5,
आपने पढ़ा है फंडामेंटल कैटलॉग 5 क्या होता है?
ये सब पढ़ा है मैंने.
तो बता क्यों नहीं पा रहे भाई? नोट्स नहीं बनाते हैं, सिर्फ पढ़ लिया आपने और उसके बाद नोट्स नहीं बनाया. तो जब नोट्स नहीं बनाओगे तो बताओगे कैसे? When you have not written a single line on FK5, how can you explain it to me? See, these are the problems that I'm telling you. If I would be, not pointing out these mistakes, what will happen? You would have a MTech degree with zero input. तो आप लोग अपने नोट्स वगैरह प्रॉपरली बनाइए जैसे क्लासरूम टीचिंग में बनते थे. इसका कोई एक्सक्यूज नहीं है, ये आप बच जाएंगे उससे.
सर मैं yes sir. FK5 is a catalog of 1535 bright stars compiled from a large number of meridian observations. The formal uncertainty of the FK5 star position were about 20 to 30.
कहाँ से पढ़ रहे हैं आप?
तो ये मैंने PDF में अपना हाईलाइट किया है. तो जहाँ से मैंने वो yes sir.
PDF में आपने हाईलाइट किया हुआ है। ओके,
यस यस सर।
हाँ, तो अब इसमें क्या आपको समस्या है वो बताइए।
हाँ सर, हाँ सर, इससे हम कैसे रेफरेंस फ्रेम को समझ सकते हैं सर, बस क्योंकि इसमें तो सर इसमें स्टार्स की
आप
बात हुई थी।
अब आप इसको ऐसे समझिए कि whenever you talk about reference frame, है ना, तो आप मुझे पहले एक बार जरा बताइए what do you mean by reference frame?
सर रेफरेंस फ्रेम इज समथिंग लाइक, जब हम सब किसी चीज को सर किसी के रिस्पेक्ट में डिफाइन करते हैं, अगर सर मुझे डिस्टेंस भी अगर कुछ बताना है तो एक रेफरेंस लेके बताते हैं। तो सर जैसे हमारे जो 3 रेफरेंस हैं, एक्स रेफरेंस एक्सिस है एक्स वाई जेड, अगर सर हमें इसको भी डिफाइन करना है तो एक फ्रेम चाहिए। कोई पॉइंट अगर हम स्पेस में ले रहे हैं सर, तो उस पॉइंट को अगर हमको किसी भी रेफरेंस से बताना है सर, तो हमें एक फ्रेम की हेल्प से हम बताते
नहीं
हैं
नहीं,
सर।
आप भटक गए। देखिए सुनिए, सभी लोगों के लिए it is when I say something to certain person, it is not for him, it is for all. Okay, so reference frame is something which is helping us in realizing the conventional systems or reference systems. तो अभी आप फॉर एग्जाम्पल, जस्ट फॉर कॉमन लेमैन, आप किसी एक्टर को देखते हैं, अरे उसने बड़ी अच्छी जैकेट पहनी है, ठीक है ना, या किसी ने बड़ा अच्छा सूट सिला है, तो आप दर्जी के पास क्या जाते हैं कि भाई मुझे भी ऐसा ही सूट सिलवाना है। एट दैट टाइम यू आर वेरी आइडियलिस्टिक जस्ट बाय लुकिंग एट सम अदर गेटअप कि ये मुझे भी पहनना है, ये मेरे ऊपर कैसा लगेगा, मैं इसको देख, तो आपने मन में तो बना लिया कि आई जस्ट वांट टू हैव दोस clothes over me. But when you go to the tailor and then ask for your real measurements, and sometimes when you wear that particular clothes which you stitched up doesn't look suits good on you. So is case mein, what is reference system? Reference system is something which is idealized. What you have is imagined that I want my system to be like that. And at the same time, reference frame is something which is helping us in realizing those systems. In our case, these frames are nothing but collection of very strong control points or very good stable control points. That's what these reference frames are. In the case of celestial domain, these frames are catalog of very stable quasars, stars. And in the case of terrestrial frame, these are the collection of ground control points established over the earth surface around the globe. ठीक है,
यस सर।
समझ में आया कुछ?
जी सर।
फिर आपने लिखा है व्हाट इज प्रिसिशन न्यूटेशन मॉडल। अभी देखिए मॉडलिंग पे मत जाइए बहुत ज्यादा। मॉडल इज समथिंग, आपको मैं एक सिंपलेस्ट टर्म में बता देता हूं, दीज मॉडल्स आर हेल्पिंग अस टू करेक्ट आवर पोजीशन at a certain epoch if we apply those correction to our position. So let's say we have computed our position in celestial space or celestial system, and if we have not applied the precision in nutation, so what will happen? There would be a zigzag pattern of the position in time series domain, because if you have not corrected it, it would have oscillation properties of the precession and nutation phenomena. So what we do, we apply those corrections to avoid this the so-called periodicity in our position. So these models are available, very well defined model. I can name it also, just I need to see it. There is a very beautiful name of these models which people used to apply, and these models are available. You can use those models for correcting your positions. And there are several models are available which you can refer to. What is next problem? How 0.5 milli second of position uncertainty of radiosemic accuracy for the orientation of the axis is about 0.02 MAS. अब आप खुद ही समझिए कि आपने जो एक रेडियो एक्स्ट्रा गैलेक्टिक रेडियो सोर्सेस की जो एक्यूरेसी एस्टिमेट की है, वो ऑब्वियसली वो क्या है? आप मतलब इसमें आप ये समझिए कि ये बोला गया है इस क्वेश्चन का जो आपने तो सिर्फ क्वेश्चन कॉपी पेस्ट कर दिया है. You even don't know what is the motive behind this question. The question says that even the lesser accuracy at the position uncertainty of a radio source which is very far from away from you would give you the better precision in your orientation of the axes. And the reason is very simple, because you do not have only single source of this radio source in the space, in the celestial space, but instead you have various such sources which are helping us in achieving the orientation of the axes. This is meant by your the so-called the large number of observation are taken up for estimating the same, which is the orientation of the axis. तो आपको बहुत सिंपल मैं आपको बता दूं कि आपने सिग्मा मीन को बताया था कि सिग्मा ऑफ मीन, स्टैंडर्ड एरर ऑफ मीन वुड बी स्टैंडर्ड एरर ऑफ द इंडिविजुअल ऑब्जर्वेशन डिवाइडेड बाय रूट n, दैट n वुड बी सो लार्ज. तो अगर आप 1000 एक्स्ट्रा आपके में, अभी आपने FK5 में बताया कितने कैटलॉग हैं आपके? FK5 में बताया आपने 1535 हैं. ठीक है. तो अगर आप सभी की पोजीशन एक्यूरेसी बता दीजिए 0.5 है, तो आप 0.5 डिवाइड बाय, इन जनरल में बता रहा हूं, अभी तो मॉडल भी मुझे नहीं पता है कि वो ओरिएंटेशन ऑफ द एक्सेस कैसे करेंगे, बट आप सिंपली 0.5 डिवाइड बाय स्क्वायर रूट ऑफ सो कॉल्ड 1535 रखिए, तो आप देखिए आंसर आपको मिलेगा 0.0127619. That means it is near about 0.02.
Yes, sir.
You get it?
Yes, sir.
So this is what is meant here. Although still, if you choose a better model, I've just used a simple averaging model to make you understand that how this lesser uncertainty or position uncertainty of radio source in one source could make it to help us in representing the better orientation of the axes. Okay, so fourth, 550 question, how the fourth dimension time considered as an important parameter in space? अब आप खुद ही बता दीजिए इसका आंसर. Everything is related with the time. If you are defining something, it is at with respect to certain epoch. If you are computing something, it is with respect to some epoch. Today you are solving this satellite position, you will compute through some algorithm. It will be certain with respect to certain epoch. Even the rate of change in the axes or in the planes of the satellite orbit would be with respect to certain epoch. So when everything is referred to something which is the epoch or at epoch, that's why the time is considered as a important parameter in space units, because everything is related with the time. Every model is available with respect to time. What is Greenwich R angle of the mean sun? अब आप मीन सन पे बताइए. आपको पिछली बार भी मैंने बताया था GMST, GAST. तो जो आपका GMST है, यानी कि ग्रीनविच मीन साइडरियल टाइम और ग्रीनविच मीन सोलर टाइम, दीज आर विद रिस्पेक्ट टू द मीन सन एट योर इपॉक. तो अगर आप ग्रीनविच मेरिडियन पे खड़े होकर के मीन सन से एंगल कंप्यूट करेंगे एंटी क्लॉकवाइज डायरेक्शन में, तो दैट वुड मेक अस द ग्रीनविच मीन सोलर टाइम. यस. What is the conventional terrestrial pole? यार ये तो बहुत बेसिक क्वेश्चन है. टेरेस्ट्रियल पोल आपको मैंने बताया हुआ है कि द कन्वेंशनल टेरेस्ट्रियल पोल इज द रीजन. पहले तो आप ये रीजन देखिए, द रीजन व्हाई इट इज डिफाइंड. आपको मैंने बताया हुआ योर z एक्सिस इज continuously, that means the earth rotation axis is continuously moving in previous many years. It is because of various effects over it. That is why we study the polar motion and the polar wander in the previous slides. So in the polar motion case, since your z-axis is not stable, or the earth rotation axis is not stable, so how do you define a coordinate system if your the z-axis or the earth rotation axis is not defined? So what you do, you take the average of 5 year of observation of the earth rotation axis from 1900 to 1905, and then you take the average value of that 5-year observation as the intersection point of the rotation axis with earth crest, and the line joining to that intersection point from earth origin is called as conventional terrestrial pole, or CTP. You could read it more about the CTP in many of the books where we talk about the so-called conventional terrestrial pole. I don't know, have you read it about it or not? But it is perfectly written that you take the average of 5 year of observation from 1900 to 1905, and that averaged value would be considered as the CTP. Okay.
Yes, sir.
What is supplement on precise timing from GP? अभी टाइम सिस्टम पढ़ाएंगे तो थोड़ा सा और डिटेल से चलेंगे. अभी इसमें तुरंत कुछ भी बताना जो है वो अधूरी नॉलेज होगा, जो कि आपको बैकग्राउंड नहीं पता है. चलिए भाई पढ़िए पहले. ये सब मतलब अनएक्सपेक्टेड नहीं था मेरे लिए. मुझे मालूम था कि आप उसको बहुत केयरलेस होकर के चला रहे हैं. चलिए और क्वेश्चंस भी हैं. देखिए भाई, क्वेश्चंस जो आप लोग भेज रहे हैं वो सब वो वाले हैं, किताब से आपने हाईलाइट किए हुए हैं. शुभम ने क्वेश्चन जो भेजे हैं मैं वो जूम करके एक बार पढ़ लेता हूँ, फिर मैं आप लोग को बताता हूँ क्वेश्चन क्या है. स्पेस फिक्स्ड क्वेश्चन बेटा क्या है? आपके जो हाईलाइटेड हैं वो हैं या बगल में जो लिखा है वो है?
सर जो साइड में लिखा है.
What is a space fixed conventional inertial system and frames? क्या भाई आप लास्ट क्लास नहीं अटेंड कर रहे हैं क्या? कुछ पीछे कुछ क्लासें मिसिंग है क्या आपकी?
स्टार्टिंग के 3 क्लास सर.
सुमित, आप वीडियो रिकॉर्डिंग डाउनलोड कर रहे हैं?
यस सर, कर लेता हूँ सर.
भाई इनको भेजिए, क्योंकि बहुत बेसिक क्वेश्चन है. पहले एक बार वो वहां से पढ़ेंगे तभी ज्यादा बेहतर होगा. बहुत बेसिक क्वेश्चन आपने पूछा. इनफैक्ट आपके दूसरे क्वेश्चन का तो मैंने जवाब दे ही दिया है. व्हाट इज रेफरेंस सिस्टम एंड रेफरेंस फ्रेम, है ना? वो सब बहुत बेसिक क्वेश्चन. आपने लग रहा, मुझे लग रहा अभी बनाए हैं क्या?
तो सर मैं पहले से ही पढ़ रहा था.
हाँ?
सर मैंने पहले प्रेजेंटेशन पढ़ा था, जो नोट्स मिला उसके बाद बुक पढ़ा था ये.
व्हाट इज राइट असेंशन एंड डिक्लिनेशन? ये तो बहुत बेसिक क्वेश्चन है.
तो उसके बाद मैंने सर देखा था लास्ट ईयर वाले जियोडेसी के नोट्स में, तो वो चीज मैंने खोजा था तो हो गया था.
लास्ट ईयर का नोट्स.
लास्ट सेम जियोडेसी वाले नोट्स में सर.
हाँ. चलिए और कोई शेयर करे? आलोक.
यस सर.
देखिए आइडिया इस इंटरेक्शन का ये है कि आप दो फायदे होंगे उसके. पहला फायदा तो ये होगा कि आप लोग टेक्निकली करेक्ट चीजें बोलेंगे. टेक्निकली करेक्ट इन द सेंस कि यू नो sometimes we say, and in our mind we think the right answer, but when we speak we technically are not correct in speaking the statement. So it is better that you should speak and discuss the more or less the content which we are teaching you. You should discuss it so that the more times you should speak the right technical content. ओके तो ये शेयर किया हाउ वी मेक ऑब्जर्वेशंस विद VLBI. देखिए VLBI इज नोन एज द वेरी लॉन्ग बेसलाइन इंटरफेरोमेट्री. ओके
Yes.
नाउ the full form of VLBI is very long baseline interferometry. So in this VLBI nothing special happens. It is only that the very large telescope. Let me just share with you the VLBI telescope. It's very huge telescope. You know? You see, you would be taking to your surprise. You just search on Google the VLBI telescope. So these telescopes are your so-called what they are doing. They are you know collecting the radio signals from quasars that is very far away from the Earth's surface, and these telescopes are placed on a different continent. So let's say one is placed in India, another is placed in Eurasian plate, somewhere in Europe. So for that quasar, the distance between the two position, one is in India, another in Australia, or maybe in somewhere in Europe, doesn't look different. For them, it is very, I mean, the baseline between the, or the point between the Indian Eurasian or Indian Australian plate was very, very less compared to the distance between that radio source to that Earth surface. So what they are targeting the two radio signals which is coming from same source of signal to both particular telescope, and they are using these radio signal and they are inferring it. That interferometry is performed where the phase of the signal is being used to measure the range between point of quasars or the radio source and to that telescope. And similarly, other quasars are also used to measure the range. Once the range is measured, the position of the or the distance between the two continents is measured, frequently. Any change in these position would be considered as the change of motion or the motion change between the plates, and that is being done very precisely over the years. So VLBI is the one of the popular technique of the old or classical geodesy. Before even GPS, people were working in the VLBI because they have prepared or developed this. Unfortunately, in India, we do not have any VLBI telescope. So if you see IVS service, Indian International VLBI service, and the stations, there would be no station on Indian continent. Okay, that is a very classical technique of the space geodesy. So the distance between two station, one at Indian plate or other would be in somewhere in Australian plate, would be measured. This distance is actually measured and the change is recorded, and that change is recorded and it is estimated throughout the year. And and one more thing that I would like to tell you, that VLBI is particularly used for estimating the Earth rotation. Just like SLR is used for estimating the center of mass of Earth, this VLBI technique is used for estimating the Earth rotation component. Okay, so better you measure it, the better your time system would be. So it is indirectly related with the improving the time system. चलिए आपका अगला क्वेश्चन देखते हैं. What is the difference between LMST? तो ये तो आप देख सकते हैं, इसमें कुछ नई चीज नहीं है. आप फिगर बनाइए, आपको दिख जाएगा. Equation of equinoxes, sometimes it is called as. What do you mean by non-rotating origin? ये आपने कहाँ पढ़ा?
सर
थोड़ा सा रेफरेंस मुझे चाहिए होगा कि किस जगह की चर्चा हो रही है. आप मुझे वो बता दीजिए, आपने किस जगह में पढ़ा? सीबर की बुक में पढ़ा है या
सीवर की बुक में है सर?
ये सीबर की बुक में है?
हाँ सर.
हाँ बताइए.
सही सर.
हाँ जरा जरा 1 मिनट रुकिए, जरा 1 मिनट रुकिए, 1 मिनट रुकिए, 1 मिनट रुकिए, ऊपर चलिए, जरा हल्का सा ऊपर चलिए।
सर यू आर नॉट ऑडिबल सर।
अरे मैं कह रहा हूँ आवाज आ रही है? इज इट ऑडिबल टू यू नाउ?
अभी हाँ सर, अभी आ रही है।
हाँ जरा ऊपर चलिए, जस्ट स्क्रॉल अप। तुम्हारा नेटवर्क स्टेबल नहीं बेटा? हाँ हाँ yes, just above the bottom of the previous page. ऊपर चलिए, इसके ऊपर, इसके ऊपर।
यहीं कहीं।
जस्ट अबव। आर यू लिसनिंग? आवाज आ रही है?
यस सर।
बस बस बस। शिवम, काइंड अटेंशन। शिवम, ये लाइन, लास्ट लाइन पढ़िए, क्या लिखा है? It is established through conventional direction to the mean orientation of the polar axis over the period 1900 to 1905, and this would be known as conventional terrestrial pole. यहाँ साफ साफ लिखा हुआ है what is CTP. चलिए आप कंटिन्यू होइए, आगे बढ़िए।
रोटेशन का तो ये सर ये according for the rigorous definition of sidereal rotation of Earth based on the early concept of non-rotating origin, the terrestrial ephemeris origin and the celestial ephemeris origin defined on the equator of the CIP will be introduced.
Let me just read it once. Accordingly, for the rigorous definition of sidereal rotation of Earth, based on the early concept of the non-rotating origin, terrestrial ephemeris origin, and celestial ephemeris origin, defined on the equator of the CIP conventional intermediate pole, will be introduced. Okay, it is related with the. Okay, I get it. So it is related with something related with the definition of the time system. Okay, so what happens is that I mean, obviously, since when you consider the Earth to be at the center of the celestial sphere, you basically take the assumption of it, and see, it's very simple. You think of celestial sphere, and when we consider this celestial sphere, we consider Earth not as a planet, but as a origin of that particular so-called particular sphere, and that Earth is rotating, as you know. So here they are taking assumption that when we consider or take the assumption for the celestial sphere, we consider that the Earth at the center of this sphere is not rotating. So basically they are referring to the non-rotating origin. It means they are referring to the Earth as a body who is considered as the origin of that celestial sphere. Okay, next is how to define ephemeris second. कहाँ पे पढ़ा है, जरा ये भी रेफर करिए ले चल के. सीबर में ही पढ़ा है क्या?
हेलो
अरे
हेलो
सीबर में ही पढ़ा है.
यस सर.
So it is the International Atomic Time Scale, which was introduced to meet the requirements for an early, accessible, and strictly uniform time scale. है ना? The unit of atomic time was selected in such a way that it equals the duration of the ephemeris second. अब आप बताइए ephemeris second क्या हो सकता है? तो देखिए ephemeris, वही मैं कह रहा हूँ, मुझे थोड़ा सा रेफरेंस चाहिए, क्योंकि ephemeris second क्या है? It is one sidereal day is 4 seconds short of one solar day. That means if solar day is of 24 hours, then sidereal day would be of 23 hours 59 minutes and 56 seconds, somewhere 3 minutes 56 seconds shorter to a solar day. So the sidereal second would be divided by this one by this total segment of 24 hours. For a normal second, for a normal second, we just divide 1 by the whole 24 cross 60 cross 60. But here in the sidereal day, we just simply divide it by this 33 hours 59 second 59 minutes and 56 seconds. So this is the whole duration which we have to use. So the ephemeris time is basically defined based on the sidereal day, one sidereal day. अभी थोड़ा सा टाइम सिस्टम बाकी है, वो आप लोग के डिस्कशन के चक्कर में अभी रुका हुआ है. ये जो डबल कॉलम वाला है, ये इसमें कहीं लिखा है क्या आपका एफेमेरिस वाला, कि सीबर वाला आप बता रहे थे?
सर ये तो दिखाने के लिए कि मीन्स आप बोल रहे थे ना, रेफर कर रहे थे कि ये तो मीन अरे साइड को उसके लिए था.
ओके.
और सर ये डायग्राम मतलब यहाँ पे जो लिखा हुआ है एक्स्ट्रा रोटेशन नीडेड टू कंप्लीट वन सोलर
तो
डे,
उसका कारण है ना
ये
कि आप
मतलब समझ.
हाँ, उसको समझ में कैसे आएगा, मैं आपको बताता हूँ ना. ये फिगर जो आपके पास है, if everybody is looking at, it's a very beautiful figure that explains when you are in this position, let's say. So move your cursor to the so-called yes. So in your just drop this minimize it. So this figure says that when you are looking at your position from the surface of Earth towards the sun, so you would again be looking at the same sun in 24-hour rotation. Please remember, okay? But sidereal is never measured with respect to sun. Sidereal time is measured with respect to a distant star that is very far from away, beyond the sun too. That means the distance between Earth and that star would be greater than the distance between Earth and that our sun. Okay. So if you are observing that star instead of sun, you would come 4 minutes early to that, or you would be looking at that star 4 minutes early to complete a solar day. So let's say you are observing the sun and at the same time you are observing the star, and after one whole complete rotation, one full rotation of day, you would be looking at the star 4 minutes earlier than you are observing the sun. So that is the difference between one mean solar day of which is says as 24 hours 3 minutes 56 seconds in sidereal time. So it is somewhere difference between one solar day and sidereal day is positive 3 minutes 56 seconds. Okay. इसका तो फिफ्थ क्वेश्चन इज वेरी सिंपलर. आई हैव एक्सप्लेन्ड इट इन द लास्ट क्लास आल्सो. Barycentric means the moment we change the center of the whole solar system as the center instead of Earth, that will be the barycentric celestial reference system. Yeah, the seventh question, we need to take one class on the reference frame, directly on reference frame, where we will estimate and see the no net rotation. So ideally, when you looking at the no net rotation condition, so it is basically saying that there would be no residual of the rotation when you are observing Earth as a rotating body. There should be no net rotation. It should be zero. Only then your angular momentum would be conserved. Otherwise, if there would be any additional rotation, your angular momentum would not be conserved because it is something I dot omega. Okay. So if there is no, I mean, obviously, omega is a vector quantity, isn't it? Are you getting it, Alok?
Yes.
So if you take the vector direction to the rotation every time, if you take the vector rotation, vector direction, just like you are as if you are working in the vector calculus or something where you take the every unit direction. So it is said that no net rotation condition says that you should sum the W, delta W, which is Wi, Wj, Wk, Wl, and there would be nth direction of individual rotation. So for sum of all these rotation would be equal to 0. That means there would be no additional rotation in any of the direction. So let's say your Earth is rotating, you take a surface, you make a tangent to the surface. So every time Earth is rotating, you make a tangent to that rotation. So that would be having different tangent at different epoch. So W1, W2, W3, W4, W5, W6 up to that whole 1 day rotation. So if it is said that if you are observing any additional residual, ideally it should be 0. But if you are observing any additional term in the rotation, so that in that case we cannot define the system. So no net rotation condition exists. I will explain it when we discuss the reference frame. तो ये डिस्कस करेंगे अभी. ओवरऑल इसके अलावा कोई क्वेरी हो आपकी, क्योंकि जो कंटेंट है दे मे हैव ए डिफरेंट कंपोनेंट, they may have different technical nomenclature that is written which you have not studied before, but believe me, this is one such uh, literature which you must know, not as a student of Geo-Informatics only, but as a student of physics, as a student of mathematics. You should aware about your Earth, how your Earth varies, what are the different aspects of the Earth. People are not reading or not paying attention to the basics of the celestial mechanics or Newtonian mechanics on Earth. But I must say that you should go through these content. Okay. Who else remained? Sumit and Valley Shetty.
Yes, sir. Sir, should I share my screen?
हाँ बिल्कुल. It is good practice that you highlight the content on your Word file in this MS file. It's a good content. अभी थोड़ा टाइम सिस्टम को छोड़िए, अभी टाइम सिस्टम स्टार्ट ही किया था भाई, अभी टाइम सिस्टम पे तो आ ही नहीं है अभी ढंग से. टाइम सिस्टम को थोड़ा स्किप करिए, कोऑर्डिनेट सिस्टम पे चलिए. टेरेस्ट्रियल, सेलेस्टियल एंड एसोसिएटेड जो इफेक्ट्स हमने आपको बताए. लेकिन ये बहुत बढ़िया चैप्टर है. दिस इज वेरी नाइस चैप्टर. the book, the chapter 2 which I sent from this Tunisian book. Very good chapter.
सर अभी इसमें ज्यादा नहीं पढ़ा था सर, वही रेफरेंस फ्रेम वाला पढ़ा था तो उतना ही था सर. उसमें बस एक डाउट था सर, जो पैराग्राफ में हाईलाइटेड है सर, वो समझ सर. यस सर. सर यहाँ पे ये पैराग्राफ सर समझ में नहीं आ रहा है, ये मतलब कि ये यहाँ के बाद कह रहा है दिस सर it was based on the time variable in the theory of motion sun related to earth's Newcomb's ephemeris sun. सर एक तो ये what is Newcomb, and this theory suffered from the omission of relativistic theory, the dependence. सर ये बात समझ में नहीं आ रही थी।
वो आइंस्टाइन थ्योरी ऑफ रिलेटिविटी की बात कर रहे हैं यहाँ पर। समझ रहे हो? उसको हम लोग डिस्कस करेंगे व्हेन वी डिस्कस अबाउट द टाइम सिस्टम इन डिटेल।
ओके सर, वन मोर थिंग सर, जैसे
हाँ
2-3 बार सर चीजों को पढ़ रहे हैं, फिर उसके बाद फिर भी लग रहा है कि जैसे क्लियर नहीं हो रहा। जैसे अब अगर हम उस टॉपिक को अपने हाथ से कॉपी पेन में लिखने बैठते हैं ना सर बहुत ज्यादा चीजें रिकॉल नहीं हो पा रही सर। ये हो रही सर।
See, these problems I have faced also. Please, that's what I'm saying. I could not get this such type of content which is very much very popularly available nowadays. We would not having that much luxury of having new books. We were having only like Sieber and these books. So we have developed our understanding from those books only. But yes, it is very true that it is not in one go that you will get everything. I'm not expecting that also, but I'm not even expecting that you should ask me what is reference system and frames, because it should be you should be aware of these two components. What I'm interested in, you should at least ask those questions which needs little discussion, so additional discussion would be there on that. But yes, it is true that you could not get it in a single go. You have to read it twice, thrice. But please remember that these understanding once developed will remain throughout your life. Okay, so be patient. Don't hesitate in reading again and again. If you read something more twice, thrice, it would help you in connecting the bridge between your old classical geodesy to present day GPS. It is this linkage is very important. You cannot jump it. Okay. वैली शेट्टी, आप बताइए।
Sir, shall I share my screen?
Yes, yes.
Sir, is this visible?
Not yet.
Sir, is this visible?
Just a minute. अभी भी नहीं आ रहा है, स्क्रीन पे नहीं आ रहा है।
Sir, it's showing that it is shared the entire screen.
हाँ, शेयर करिए, आप इंटायर स्क्रीन करिए।
I opened it completely, sir. Word page.
You just send me this Word file on chat box, okay?
Okay, sir.
भेजा आपने?
Yes, sir.
Okay, what is Keplerian motion? बताइए, Kepler's theory of motion क्या है? Have you studied Kepler's theory of motion?
No idea, sir.
So when we study about or discuss about the satellite motion around Earth, na, so we will start with Kepler's law. Okay?
Okay, sir.
So at that time it would be covered. अभी Keplerian motion पे मत जाइए. It is simply saying that motion of the satellite around the Earth. ठीक है? Second is first point of Aries. Now first point of Aries is very simple. Just go back to your notes and you see the point where ecliptic and the celestial equator intersects. You remember that figure?
Yes, sir.
The intersection of ecliptic plane and celestial equator, the line joining that center of Earth to that intersection point points towards first point of Aries. Now the first point of Aries is nothing. It is a star which is marked as the in your theory of zodiac notions, where you have several such markers. So this first point of Aries is something which is at that epoch, at the epoch where you are defining the x-axis for the celestial system. So this
Sir, then
x-axis
vernal equinox is also pointed
same
the
same as vernal equinox is same as first point of Aries. Okay.
Okay, sir.
अब आप जब ये क्वेश्चन पूछती हैं, then I am little upset. What is precession in nutation? I've explained it. You can go through the video lecture. It is very well explained. Have you not attended the class?
I attended, sir.
Then what is the problem? Just tell me, what is the problem in understanding precession in nutation? What part you could not understand? Just please let me know.
One second, sir. I'll open my Sieber book.
Sorry?
Sir, the lines you gave in PDF are somewhat clear, but the lines in Sieber book are not. I'm not getting that meaning, sir, from the lines of Sieber.
So
Precision and mutation part.
just open that lines. Let me just see what component. I mean, the theory of precision cannot be changed from book to book. It should be same. It is only matter of how they are writing it and how you are understanding it.
Here they said that total motion is composed of a mean secular component, that is a precision, and a periodic component. Total motion they divided into two parts as precision and nutation, sir.
कहाँ
Here
पे लिखा है?
I'm
Page number?
page number 18 of Sieber book.
Just please wait. Page number 18. Okay. अर्थ, हाँ तो बताइए टोटल मोशन इज कंपाउंड. हाँ ठीक है, तो अब व्हाट्स द प्रॉब्लम?
Then next, the respective star coordinates are in the next paragraph, fourth line, sir. The respective star coordinates are termed as mean positions or true positions. This mean secular component and mean position, that words I'm not getting, sir.
You are not getting the mean position or true position. The star coordinates are termed mean position or true position. Is it?
Yes, sir. Precision, other name they are calling as mean secular component, na sir. Again, they are saying here the star coordinates are termed as mean positions.
No, that's what I'm saying. You are confusing it with the different thing. See, precession and nutation is a phenomena. First, just let me very frankly tell you, for all of you, those who have little confusion, the precession and nutation is a phenomena. Not, they are not stars. They are phenomena. You understand what do you mean by phenomena?
Yes, sir.
It is phenomena that is occurring or because you have a very vibrant earth rotation axis. Now it is saying, it is what it is saying that the position and orientation of equatorial plane and the first point of Aries is called mean equator and mean equinox. The reason, because at any instant you cannot define these two, because at any instant, and instant to instant or epoch to epoch, they would be varying. As you can see in this figure 2.5, just above the sign of vernal equinox or first point of Aries, you see an arrow is mentioning left, towards left.
Yes, sir.
That arrow is saying that over the period of year, this intersection point will move from this place to another place in that direction, but it will take 26,000 years to come again at this position. In order to simplify your measurements so that you could measure something, you could refer to something, you need a mean surfaces, you need a mean equator, you need a mean equinox, because that will help you in estimating the position. Otherwise it will be very difficult to measure something, because in celestial space it is very vibrating, it is very dynamic in nature. You cannot hold to a single point of intersection for a fraction of second. That's mean that I wanted to say here. So the term mean equator, mean equinoxes is for our help that we could measure something. Okay.
Okay, sir.
Followed by what is written is more important, that the position and orientation of the equatorial plane and the first point of Aries is called mean equator and mean equinox respectively, when only the influence of precession is considered. Okay?
Yes, sir.
When nutation is taken into account, they are called as true equator and true equinox. The reason is simple, because they are short periodic. So if you would imagine that there is no nutation phenomena, then you would be working with the mean or mean equator or mean equinox. But when the nutation phenomena is also involved, and when you correct for the nutation phenomena, then you would be somewhere actual equator and true equinox. That means you are somewhere near to the reality.
Okay, sir.
So when the respective star coordinates, that means star, when I say when somebody says star coordinates, that means any star within that celestial body which you want to measure the position of would be termed as mean position of that star, true position of the star.
This means that only for calculation based, to make it easy, we consider these assumptions.
Yes.
That too only when we consider nutation effect.
The true word will come when we take nutation into account.
Okay, sir.
See, there is one point or one suggestion which I want to give. If you go into depth of every aspect, you would not get the whole summary. So my suggestion is to first is to get the summary. When you get an interest, then you go into depth of individual aspect, at this instant, you should just know about precession, you should know about nutation, their consecutive effects, as well as how you are referring your coordinates. So that the 2.17 is saying mean position can be transformed from reference epoch T naught to the required observation epoch T using the precession matrix.
But
So
sir,
they are
as we are going on reading the content, it is not in our it's not understanding that we are going into depth of the concept, but we are thinking that it's
I
not
agree.
understanding.
I agree. I agree that I agree, because since you are reading it first time, many aspects which you have not considered, or you are not prepared enough to read that content, sometimes it gets difficult. But that's what I'm here for, to discuss, discuss the confusion which is making you, less comfortable in reading those statements.
It's like that if we read one sentence, it is we are getting a feeling that we understood. Again, if we go to a second or third sentence, again the first or second sentence meaning is changed, is being changed. We are feeling so like that.
No, but do not get confused. This star coordinate, which it is written in the fourth line, it is of about the in any independent star for which you have to take the measurement. But for that, you need have very stable or very precise, definedly x-axis as well as the plane. In order to define that plane, you need to consider the precession and nutation. If you do not consider that precession and nutation phenomena, your planes of measurement on which you are taking the angular measurement cannot be defined. It would be varying in nature. It would be unstable. If your z axis is disturbed, obviously z axis is perpendicular to the equator. Your equator would also be disturbed. So you have to first fix the z axis. Once the z axis is fixed, then only your equator would be stable. So precession and nutation are the effect occurring on the z axis. That means earth rotation axis. So if you make corrections over to that rotation axis for precession and nutation, once you correct for it, then only your equator would be stable. Otherwise, it is simply perpendicular to the rotation axis. If it is rotation axis is having disturbance, your equator will also be not stable. It would be also varying in nature or oscillating in nature. How can you make the measurements? You getting my point?
Yes, sir.
Yes. What else?
So time tagging in
Time
31st
tagging is
page.
time tagging is something which is the time tagging is meant for stamping. This time tagging is stamping. This epoch is something which is epoch is a different world in terms of terminology. Epoch refers to the particular time for which an event is occurring. So epoch and time taking would have a same unit, but time taking means you are tagging a particular task at the same time. But epoch is something which is referring to occurrence of an event. Just like any event in your galaxy, something is happening, you would refer to as a epoch. But if you are as a human, you are doing something, you are putting the time to a particular task, that is time taking. So epoch is generally used for an event which is occurred, and they both have the same unit. They would be referred in seconds. There's no problem in that, but the only way how you are representing one definition to other, it is different.
Okay, sir.
So let's say we are taking the class at 3 p.m. Okay, so that is time tagging. But if any such uh, event, if some event that is not in our control, if something is happening, that is epoch. At that epoch, something has happened. At that epoch, this so-called uh, this event has occurred. Satellite altimetry, that means it is referred to the sea surface topography. So dynamic topography is where you have a lot of disturbances in the topography. Popularly, satellite altimetry is used for sea surface topography estimation. But anyways, it is basically for the estimation of the when you measure it or use it for general topography purpose. So you use it with the varying undulation. You would use it as a dynamic topography. Where did you read about this exact definition of the datum?
Sir, actually, in previous sem we have a GIS subject, na sir. In that course, the datum definition we learned like it is some reference against which we make measurements like that. Different surface or point again which we measure. We measure something using some models.
Very true. Very true.
But in referring to the PDF here, it is just like it is some some 2 points here mentioned, sir, like size and shape of the Earth approximated as an ellipsoid. In PDF.
See, the problem is not with the definition. The problem is simple, that you need to understand one point, that your datum is basically referring to how you are defining your point. So if you are defining three-dimensional point, you would be referring to horizontal datum for 2D coordinates and then the vertical datum for third coordinates. Okay. So datum in general, if you define datum in general, it should be referring to a reference. But when you come back again in this aspect of coordinate system, datum is something about the so-called vertical. I mean, we are more focused on the physicality of the third coordinate. How do we defining the 3D position? So we are more referred towards the vertical position. So we define the datum in for three-dimensional. The height of a particular point with respect to some reference. So that we define as a datum. But in general, the general definition of datum is always having a reference through which we can define something. But in this GPS or the classical definition of datum, we define the datum as the vertical datum.
Sir, in satellite altimetry, here it is given as dynamic topography equals to ocean minus ellipsoid distance, sir. But if we refer to the image beside that, the indication is given only between the geoid and the surface.
Page number?
Last elements of first PDF, sir. First PDF, last third page.
Page number is still 193.
So this is the first PDF that you provided to us during the classes, sir. Elements of Geodesy 1.
Okay. I was referring to a different thing. Let me just see it. Just wait a minute. First PDF.
Last third page, sir.
Last third second. Dynamic topography is sea surface height minus geoid. Huh?
Yes, sir. In figure it is showing like that, but here in words it is written as ocean minus ellipsoid distance. Third line, third point.
Okay. Rightly said. The reason why it is said, this what should I say, this terminology which is written, it is is mentioned here. Difference which is ocean surface, I mean the ocean, minus ellipsoid distance is actually it is referring towards the geoidal undulation. The geoidal undulation is referred with respect to the ellipsoid only. So there is some nomenclature error in this figure which you have observed. When you observe the so-called geoidal undulation, that is measured with respect to the ellipsoid only.
Okay, sir.
Sir,
Hmm.
one thing I have to confirm regarding precision, sir. Sir, we say phenomenon of precision when the rotation axis, topmost point of rotation axis completes one circle in a particular period. That period is particularly called as precision period, isn't it, sir?
Precession period.
सर मीन्स है जो रोटेशन एक्सिस होता है उसका जो टॉप मोस्ट पॉइंट जो कि मतलब रोटेशन एक्सिस हमारा 23.5 डिग्री इंक्लाइंड है, तो सर जब ये चारों तरफ 23.5 डिग्री इंक्लाइंड होके एक उसका जो टॉप मोस्ट पॉइंट है वो एक पर्टिकुलर कंप्लीट सर्किल बना लेता है, तो ये कंप्लीट सर्किल को हम प्रिसिशन कहते हैं।
नहीं, इस कंप्लीट सर्किल को प्रिसिशन नहीं कहते हैं। इस फिनोमिना को कि वो एक प्रोसेस एक पाथ को फॉलो कर रहा है।
यस
circle will represent the 26,000 years that the circle will happen. The one circle will happen on 26,000 years. That is one thing.
Okay.
Phenomena. What is important is phenomena. Why this circle is going to happen. Are you getting it?
Yes, sir.
फिनोमिना क्या है? फिनोमिना है कि अर्थ की रोटेशन एक्सिस के ऊपर फोर्सेस लग रहे हैं बिकॉज ऑफ विच दिस इज कॉन्टिन्यूसली इन मोशन, वॉबल कर रही है।
यस सर। और सर जो ये सर्किल बन रहा है, इस सर्किल के पाथ में यानी पैरामीटर को ले लेंगे तो इसमें जो फ्लक्चुएशन आता है उसे हम उस फिनोमिना को न्यूटेशन कहते हैं।
दैट पाथ व्हेन अर्थ rotation axis is near to moon or inclined towards the moon or sun, the combined triggering effect, the nutation effect is when observed when it is near to nearby planet like moon, and when it exerts the pressure. And frankly speaking, it happens when your earth is near to moon during that revolution around the sun. When it is near to moon, what happens that moon also wants to apply a torque over the inclined surface of this earth at 23 degree to make it in the plane of line joining earth and moon. So when it applies that torque, it occurs as if it is applying force over that rotation axis. Eventually it is applying the torque over the earth inclined nature. It wants that earth should be in plane. It wants that earth should be in my plane. The distance line between earth and moon, that it wants that it should be in my plane, but its centrifugal force make it a reverse force away from that direction, that creates exertion, additional exertion on the rotation axis.
Okay, sir.
So it is good that few of you have explored it. That helped us to discuss a few queries. Then the last query is geodetic latitude versus geocentric latitude. ये तो basic simple है, इसमें कोई query है क्या आपकी?
No, sir. Actually, one thing I want to know that which we use mostly geocentric latitude for our measurements or geodetic
No,
latitude.
geodetic, because there is no surety that your plane would intersect at the center of Earth. It would intersect somewhere in your equator. The vertical normal would intersect somewhere in the equator, not at the center.
Only geodetic latitude we use for measurements.
Yes, yes, yes.
That's it, sir. Only single question on this.
Why sidereal time is not practical to measure? Obviously you cannot can you see the star right now? Can you go out in the sky? Can you see the star? No.
No, sir.
So the perfect and ideal system would be to observe your time with respect to a body which you continuously observe and throughout the years you have observed. So that basically you could refer to. You can practically at when how do you say that it is afternoon? It is 12. That when you see head up, the sun should somewhere just above your head,
Above.
so you can relate to your physical phenomena. That's why it is more practical. Solar time system.
Okay, sir.
See, when I will tell you that I have also not taken this subject, this principle of GPS subject any time in my career. I mean, during my PG days also at IIT Kanpur, we used to have a combined course of geospatial data processing, where we used to get some, see at that time how much is the length of the course that we used to teach. uh, Geospatial data processing has a component of GPS, also as a component of geodesy also. It's a huge course. I mean, right from the very beginning, we'll get measurement errors, least square adjustment, post analysis, statistical analysis, everything, and then the GPS component, little bit of GPS component, then the little bit of geodesy component. So it's a huge course. But I've never done a specific course on satellite geodesy or a GPS course. It is all because of reading. Yeah, we have several books. I'll share you one by one. The Sieber book is excellent book. You can start with. Sieber is a professor from Institute of Photogrammetry. There's one, sorry, Institute of Navigation, Stuttgart, University of Stuttgart. I guess I don't know. Have you seen the name of the designation of that Professor Sieber? He's retired now. It's a very old professor when he has written this book. It is when he has written the book, he was at the. I've recently seen some of the literature from that university. Yes, Institute for Navigation, I guess. Yeah, sorry. It is University Institute of Geodesy at University of Hanover. It's a very good website is there. You can just see and observe. Excellent. You can go and see the literature, mini projects. Let me share the screen. I hope it is visible. So this is This is the website. It's a Institute of Geodesy at University of Hanover, Faculty of Civil Engineering and Geodetic Science, IFE. You will see this mini research projects, physical geodesy and space geodetic techniques, position and navigation, geodetic space sensor technology. You can go to physical and satellite space geodetic techniques, and you can see the research projects. They are more working towards. Okay, anyways. So